Namaste. Welcome to the Indian Knowledge Systems primer course for children. In this session, we will look at the Vedic geometry. The Vedas form the body of knowledge that has been preserved from very ancient times, making it historically the oldest surviving knowledge system. Since they were orally transmitted, it is really tough to estimate the exact date of their origin. A study of the Vedic works revealed that our ancestors were well versed in the use of the numbers. In the Vedic era, there is an abundant evidence of usage of the decimal number system. Though we saw decimal place values from the verses of Aryabhata and Bhaskaracharya, listing of the powers of 10 for very large numbers is present in the texts from the Vedic era. Scholars have inferred that our Vedic ancestors knew the fundamental operations of arithmetic, including addition, subtraction, multiplication, division, squaring, cubing, square root, and cube root. In this lecture, we will learn a few mathematical insights from the literature of the Vedic era. Geometry originated in the ancient Vedic age in connection with the construction of the fire altars. The performance of yajnas is very important in the Vedic lifestyle. Nitya yajnas were done on a daily basis and Kamya yajna were performed for certain specific purposes. All this involved the construction of fire altar called chitis or vedis. As per the scriptures, the altar was supposed to be in the specific shape and size. It is very important that it had to be built mathematically without any irregularities. Thus began the quest for excellence in constructing geometrically sound structures. This led to the knowledge of various geometric principles. To aid these constructions, manuals were authored in a class of texts called Shulba Sutras. Shulba Sutras form a part of Grihya Sutras, which are part of Kalpa, which is one of the Vedangas. The term Vedanga is used to refer 6 branches of knowledge, namely Shiksha, Vyakaranam, Kalpaha, Niruktam, Jyotisham, and Chandaha. Shiksha is the study of phonetics. Vyakarana deals with grammar. Kalpa deals with the instruction of the rituals. Nirukta deals with the etymology. Chanda deals with the poetic meters. In ancient times, all these branches used to be studied by the Vedic scholar along with the Vedas. Now, let us try to understand the meaning of the word Shulba Sutra. In Sanskrit, a word can be interpreted in many ways. So, the word Shulba can mean 3 things: the act of measuring, the entity or result of measuring, and the tool for measuring, such as a cord or a rope. The word Sutra describes the style of writing. This style is called aphoristic. It is very short, compact, and highly terse way so that it can be easily committed to the memory. All non-essential words are dropped, and many times even verbs are dropped. We must thank numerous highly skilled scholars who have helped to preserve and understand many of these. All the constructions described in these texts can be done with cords and nails. These cords or rope must not be elastic or extensible, even mildly. Only then the measurements won't change. To understand this, it is like doing all geometric construction only with a compass and without a ruler or set square. There are 7 such Shulba Sutra texts that have survived. They are Baudhayana Shulba Sutra, Apastamba Shulba Sutra, then Katyayana, Manava, Maitrayana, Varaha, and Vadhula Shulba Sutra. Here is an image of a folio from the manuscript of Manava Shulba Sutra. This is an image from a well-preserved manuscript. The earliest among the 7 Shulba Sutras is the Baudhayana Shulba Sutra, authored by Bodhayana. It is estimated to have been authored prior to 800 BCE at least. It is made up of 3 chapters constituting in total about 520 sutras. It contains geometric procedures and principles for constructing altars. Just to get a glimpse of what this text contains, here are some of its contents. It has units of linear measurement, construction of squares, rectangles, and then theorem of the square of a diagonal, transformation of geometric figures, plans for fire altars, areas of the fire altars, specification for bricks, their sizes, the shapes, and then parameters for choosing materials in the brick making, then process of manufacturing bricks, the description of the shapes of the Shyenachiti fire altar, and so on. This is just for us to appreciate the wide array of things dealt in the ancient text. Now, let us try to appreciate how geometry was applied in the Chittis or Vedis. Let us take for instance the 3 primary altars, that is Garhapatya, Ahavaniya and Dakshina. They were famously called as Tretagni. These were altars in which every Vedic practitioner had to perform offerings daily. The Garhapatya altar is in the form of a circle. The Ahavaniya altar is square in shape. The Dakshina altar is semicircular. See, but the catch is this: the area of each of these shapes, that is the square, the circle and the semicircle, had to be the same. And they had to be equal to 1 square Vyama. What is Vyama? As per the units of the measures as documented in the Vedic era, 1 Vyama is equal to 96 angulis or finger breadths. In the modern terms, this is about 2 yards. Construction of these 3 altars involved 3 geometrical operations. To construct a square on a given straight line, then to convert a circle into a square of equal area and a square to a circle, to double a circle. The methods for all this and more are given in Shulba Sutras. Now, let us do an activity to learn the first one alone, that is to construct a square on a given straight line. As we will do it according to the instructions given in the Baudhayana Shulba Sutra. Let us say we want to construct a square using only a rope and nails. Only a rope and nails, no ruler. Okay. To build a desired square, we must take a rope whose length is same as the side of the square that we wish to construct. How to do this? This is how Bodhayana teaches us. Let the length of the string or the rope be PQ. Now, we must find the midpoint of this rope. How to do that? We can fold the rope by half. Now we get the midpoint. We can mark it as O. There we fix a nail. This is the first step. Okay. You can try this on your own. You can even try to follow it with a compass alone. Now, step 2. With O as center, draw a circle with half the length of the string as radius. That is, OP or OQ will be the radius. Thus, PQ will be the diameter of this circle with O as center. Then step 3. Here, we will draw 2 big circles. Take the full length of this string as the radius. Now, the green circle is drawn with P as center. And this red circle is drawn with Q as center. The radius is PQ. Step 4. These big circles intersect at 2 points, right? Here and here. So, we call these points E and F. We can just join these 2 points with a straight line. Remember not to use the ruler, but use a longer string. This line will touch the circles at points where here R and S. So, if you see, this line RS will be perfectly perpendicular to PQ. Now, we will be going to each of these 4 points, that is P, Q, R and S. Now, with P as center and half the length of the rope as the radius, that is this length, draw a circle. Now, we repeat the same for points Q, R and S. That is, with Q as center and the half the length of the rope as radius, draw a circle. Again, with S as center and half the length of the rope as the radius, draw another circle. Now, with R as center and half the length of the rope as radius, draw a circle. Now, we get a structure like this. If we do this, we get 4 points at the intersection of these new circles. What are all the points? Here, these 2 circles intersect at A and these 2 circles intersect at B. These 2 circles intersect at D. These 2 circles intersect at C. Connecting these 4 points will give us a perfect square, and its side will be the intended length PQ. This is how, without a ruler or a scale, a construction of a perfect square was done in the Vedic era. Now, shall we revise once? The first step is you're going to take a rope of length PQ. Now, we have to find the midpoint. So, you fold the rope. So, you get the midpoint. You mark it as O. Now, with O as center, draw a circle. What will be the radius of this circle? It will be the half of the length of the rope. Then, with P as center and the length of the rope, that is full length of the rope, that is PQ as the radius, draw a circle. That will be this green circle. And then with Q as center, again the radius will be PQ. With that as radius, draw another circle. Now, these two circles intersect at 2 points, right? Here and here. These 2 points are named E and F. Now, we are going to draw a straight line. So, when we draw a straight line for E and to connect E and F, we get 2 points which touches the circle, the inner circle. Those 2 points are R and S. What is the next step? With half the length of the rope as radius and P as center, draw a circle. Similarly, we are going to draw 3 more circles, that is with S as center and with draw a circle. With Q as center, again draw a circle. With R as center, draw a circle. Remember, the radius for these 4 circles are such that it's the half the length of the rope. Now, when we draw these 4 circles, we see that the circles intersect each other. So, those points are A, B, C and D. Now, when you connect these points A, B, C and D, you get a perfect square. We will continue a few more activities in the next part of the Vedic geometry. Dhanyavadaha.